Hey there, year 11s. Here we're going to be applying our exponential rules to solve exponential equations. So here we go. We're going to solve this by what we call solving by comparison. So we can see here we've got 4 to the power of x. This is equal to 256. Now normally, if we want to find x, we would need to remove the base 4. Now, you haven't yet learned the inverse operation of exponential base 4, so we're going to solve it by doing comparisons. So 256, we're going to try to break this down into the smallest base factor that you can think of. So 256, you can divide it by 2, and that makes it 128. Times 2 is 156. And then you can break the 128 into 64 times 2, and then you can break 64 into 8 times 8, and you can break the 8 into 4 times 2, and that's 4 times 2, and so that's 2 and 2, and then 2 and 2. So you can see here that what we end up with is that 256 can be broken down into its smallest factors, which is 2 times 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 2. How many times is that? That's 1, 2, 3, 4, 5, 6, 7, 8. So I know that 256 is actually the same thing as writing 2 to the power of 8. Okay? And that's how one of the techniques that we can do. And 4 over here, we can rewrite the 4 as 2 squared, and then that's to the power of x. Now, can you see, by comparison, they both now have the base 2. This is a base 2, and that's a base 2. So when I use our index laws, I know that I can multiply these two powers together. This becomes 2 to the power of 2x is equal to 2 to the power of 8. And now by comparison, if the left-hand side is meant to equal to the right-hand side, notice they both have a base 2. So that means if it's meant to equal, that means that both the powers have to equal. So therefore, you can say 2x must then equal to 8 by comparison. And so then x must equal to dividing 2 on both sides equals to 4. Okay, so that's what we mean by solving by comparison. If you can compare the two equations, if they are the same, then you can sort of, I guess, make common sense. It's like saying magic square plus 3 is equal to 4 plus 3. What is in this magic box? Now, since these two are the same meant to equal to each other, and they both have a plus 3, then naturally this must be a 4. And what I've done there is not using algebra, but more so using common sense and doing what we call solving by comparison. Okay, so let's go to the next problem. So part B, I'm now going to solve by comparison. Same thing again. It's 3 to the power of x minus 1 is equal to 81. And I can break down that 81 into 9 squared, which is 81. But then I know that 9 squared, if I keep continuing this, actually, I'm probably going to do a factor tree again. I'm going to move this a bit down. Let's do a factor tree again. We know that 81 is the same thing as 9 and 9, and that's the same thing as 3 and 3, and then 3 and 3 again. So that means 81 is the same thing as 3 times 3 times 3 times 3, which is 3 to the power of 4. And again, by comparison, if they both have the same base, and they're equal, that means that the powers must also be the same. So therefore, x minus 1 must equal to 4, and x will equal, add 1 on both sides, x equals to 5. Okay, so that's how you would do B. And now let's try C over here. C over here now has 5 to the power of 2x minus 4 is equal to 25 to the power of negative x plus 2. So in this example here, again, we're going to try to break the 25 here into its prime factors. And I know that this is its prime factor already. So 2 to the power of x minus 4 is equal to, now 25 can be written as 5 squared, but then it's all to the power of negative x plus 2. Now, they both have a base 5. Now, remember, you will multiply the powers with the brackets there using index laws. So this is now 5 to the power of 2x minus 4. And what students tend to make a mistake here is they often then just do 5 to the power of 2 times negative x is negative 2x, and they write plus 2, which is wrong. because what you need to understand is you're actually doing -2 times, not -2. You're doing 2 times -x plus 2, because they come together. This power on the outside, they come together. So when you multiply it, make sure to put the brackets to remind you that it's 2 times the -x and 2 times the 2 as well. So if you do that correctly, then what you will have now is 5 to the power of -2x plus 4. And again, solving by comparison, if the bases are equal, and apparently these two sides are meant to equal to each other, then the powers must equal to each other. So 2x minus 4 is equal to -2x plus 4. This gives us what? 4x is equal to 8, and therefore x equals to 2. Okay, dividing both sides by 4. There you go. So that's how you would do example 16 to solve exponential equations using comparison, solving by comparison.